I just replaced the battery on my electric bike. Now, this is the old battery, and it was good for a few kilometers before I noticed that there just wasn't quite enough power, so I needed to replace it. Yet the battery is still good for some things, so I decided to make an emergency light. This is a 12-volt light bulb. It looks like a regular light bulb, so much so that I put a red piece of tape on it so that I don't mistakenly screw it into a 120-volt circuit. But I wanted to create an emergency light and use the power from this 48-volt battery. So I needed to design something that would reduce that voltage so I could run the light, and being that we have a pretty big battery here, it's going to run that light for, I think, a long time. So, and it works like this. You just turn the battery on and flip the switch and the light comes on. So we're going to show you how that was done. Now this box, this is just a project box, and I had it left over from many years ago. Here's another one very similar to it. It's an AB data switch for an old computer. These types of connections we don't see anymore on today's computers, so I reused the box for one very much like it to do my project, and we'll take the cover off and let you have a look inside that box so you can see how it was done. Before we open that project box, we'll have a look at the connections on this battery. Now yours may be different, but what we have on the back of this battery is, well, actually a 4 connection battery here. And I'm not sure why there are 4, but all I needed to do was find out which contacts I would have to tap into to get my 48 volts. Now, in order to check for your 48 volts or whatever your battery is, you're going to need a multimeter like this one set on DC volts to turn your battery on. And I found that the 2 contacts on either side here, there are actually 4 here, 1, 2, 3, and 4, and we'll plug into those and see what we've got. It's putting out actually 53 volts, which is okay for what we're doing. I'm not sure why we have these other contacts here. I don't know, it might be for the headlight or something on the bike, but I have found my output contacts for my rated voltage for the battery. Now, we had to design a plug to fit this. So I've got this plug here that I put together, and it just fits in the end, and it has to fit the proper way. I've got it marked plus and negative, and on the battery we have a plus and a negative here. So if I plug that in, that's my plug, and it works just fine. So this is what it looked like on the inside. Just 2 pieces of metal bent up. I'm using some plastic here for the base, and the wires go in here and are clipped underneath these little screws here. They're holding down on the wires. So that's something like what you might need. Yours may be different. You'll have to design something that you can plug in to get your power to come out of the battery. Now we're just giving you a better look, a close-up of the contacts on that battery. And notice the plus and the minus signs, which we have to pay attention to plus and minus, or your LED style light bulb will not work properly. Okay, here's the inside with the top off. Now this little device here, the electronics board, is called a buck converter, and I'll include a link to that. It was purchased from Amazon. It was about $15 to buy that. The other thing that's in here is a toggle switch. And the only other component that we really need is a plug like this one. It just pops in there, and you can plug a standard electrical appliance plug into that. Like I say, we have to make sure that we pay attention to our negative and positive. I don't know if you can see that, the light is not very good. There we go. That side is negative. The bigger of the two slots is always negative. Keep that in mind. We'll talk about that later. But if you get one of these, make sure you wire it up properly. These contacts are clearly marked on the board. You have an output, a negative and a positive, and an input, a negative and a positive. And keep those right or the bulb won't light. The bulb, it also came from Amazon. And I think they're about $7 a piece, something like that. And we'll give you a link to that as well. The buck converter, pardon me, accepts up to 60 volts DC input and can have a maximum load of 10 amps. And when you first hook this up, you're going to want to see 12 volts coming out of this plug. So if you plug your multimeter into the plug and turn this little screw right here, you can watch and see when you're getting the 12 volts that you need, because it is adjustable right up to 60 volts. And that's the only adjustments that you're going to require. I just put this light bulb fixture together just for test purposes. I can plug it in and see if everything's working properly. But the reason we have a plug here, and you might want to do something else, but I put a standard plug on here so that I can take this light bulb, screw it into any lamp in my house, and then plug that lamp into this socket. So if I have a power outage and I want to read a book, I simply swap the bulbs and plug in right here and turn it on in the front.